Let's try this one. Same idea. Okay, what is the answer?
0.
Yes. Good. 0. This kind of question, whenever there's a E. All right, everybody. Okay, so this kind of question, sometimes it's better if you just plug in infinity and just look at it. E to the negative infinity over 4 plus 5e to the negative 3 infinity. Okay, that is 1 over e to the infinity over 4 plus 5, 1 over e to the 3 infinity. Infinity is a very large number, so on the top we have a 0. In the denominator we have a 4 plus 5 times 0, so that's going to be 0. Yes?
Can you just think about it as like the degrees?
You can think about it as the degrees, but we're going to the left. We're going to the left, so this is going to be 0. This is, yes.
You said like the 3 cases.
Use the 3 cases. Yeah, you can do that. Yeah.
Can
Yes.
you also think about how like E can't go past 0, so then it's just 0?
E can go past 0.
What?
E is, the graph goes like this. There is stuff on the left.
I don't know my parents' functions. I'm blaming that on you. And me.
No, I can't go past 0 on the line.
Oh, right, on the Y.
That's what.
Okay. All right. Let's do a few more. Let's see which one we didn't do. Okay, let's come back to the easy one. That's an easy one. All right. This one, what's the limit? 1. Okay, next. Now we're going to do ones that I haven't showed you yesterday. This one. There is no denominator. You cannot compare. Well, let's try plugging it in. So first, copy down the question. This is a typical question. Bless you. So this is a very typical question where you would have some issues. Okay, so first, plug it in, right? So limit as x goes to infinity of infinity squared plus 1 minus infinity. So we could say infinity minus infinity is 0? No, we cannot do that. Because remember, infinity means what? Very big number. You cannot say this one infinity is the same as that infinity. The degree is not exactly the same. So we have no idea how big this infinity is compared to that infinity. Because infinity is not a finite number. You cannot compare like this. So this is an indeterminate form, like we don't know. Therefore, can you guys let me finish? So therefore, we need to try some other way to actually figure out definitely what is the answer. It could be 0. It could be something else. But we cannot leave it like this and call it a 0. Does that make sense? Because infinity is just a really big number. There is no degree to this amount of big number. If you just say infinity minus infinity is 0, it's not a good statement, okay? Even if the answer is 0. So here's what we're going to do. We're going to force it so that there is a denominator so that we can compare. All right, so rewrite the question. Limit as x goes to infinity of square root x squared plus 1 minus x. What we're going to do is we're going to force this function to have a denominator. Do you guys kind of can guess what we're going to do?
Don't you multiply by the thing?
More specific.
Conjugate.
Yes, conjugate. We're going to multiply by conjugate, therefore there is a denominator. Okay, so then this is going to be limit as x goes to infinity of x squared plus 1 minus x squared over square root of x squared plus 1 plus x. In the numerator, please just remember a squared minus b squared and do it out in your head. You really need to do that now because you want to speed up that part so you can learn the calculus part. That's going to cancel. So then that's going to be limit as x goes to infinity of 1 over square root x squared plus 1 plus x. Okay, now if you plug in infinity, what are you going to get? 0. Because in the denominator, we no longer have this infinity minus infinity problem. We have an infinity plus infinity, and which is okay. It's just saying the infinity is getting bigger, therefore 0. Yes?
Could you also just like do the 1 over the square root x squared and then take 1 over x and then plug in infinity and that would be
Yes, you can do that.
Okay.
Yeah, because that
makes more
x
sense.
squared is the bigger part.
Okay, cool.
Okay, let's do this one. Think. I want you guys to think and not follow a formula. Guys, think about what you're doing and not just like, when I see this, I do this. Then you can only do that kind of problem. You want to be able to think through this whole idea. What's the answer? Infinity. It's just a square root graph that's going to infinity. This has to be infinity. So again, you don't have to think through this. I mean, don't just apply whatever I tell you to apply. Those are tricks to solve some, hard ones. These are just, what's going on when x is going to infinity. Think about your equation. Think about what numbers you plug in. Think about how y is going to behave. Just do that and don't go crazy with all your tricks. Okay, let's do an extra practice.
Extra practice.
Limit as x goes to infinity of square root 9x squared plus x minus 3x. A lot of you got 1/3. I'm not quite sure how, but let me work it out for you.
I know how to go.
Yeah, I think I know by looking at it. Okay, so this is limit x goes to infinity of 9x squared plus x minus 9x squared over square root of 9x squared plus x plus, oops, that should be outside, 3x. That's going to cancel. When x is going to infinity, that's going to be x over 3x plus 3x. Okay? In the denominator, this part comes out.
But where does that x go?
It's still on the top.
No.
That one doesn't matter. It's too small.
Darn it. Wait, so
If you take it outside the square root, it's going to be x to the 1/2. 1/2 degree is smaller than the first degree.
so if you have like something outside of the square root, you have to keep that even if you take the other one out.
Yes, they're the same degree. When you take it out as first degree, that's still first degree. They're the same magnitude. They're the same magnitude.
If it was like plus 3, you get rid of it.
Yeah, right. It's too small.
Okay.
So that is, shh, guys, please be quiet. Over 6x, so that is 1/6. Okay, please do not assume things outside the radical will leave. If they're the same magnitude, they have to stay. You're comparing things. Well, they are exactly expanding at the same rates. They have to stay. Yes.
If it was like 3x squared, then would it? Yeah, right?
If it comes out as 3x squared, then the x doesn't matter. The 3x doesn't
I'm
matter.
saying if it was like 3x squared on the outside.
Then then the top is expanding smaller than the
So
bottom.
then you-
Yes.
Okay.
Okay, we gotta move on. Okay, we're gonna do change of variables. So sometimes it's not possible to solve as is. We have to change some variables. So first, let's look at this question. Limit as x goes to 2 plus of arctan 1 over x plus minus 2. What does arctangent mean?
It's
The inverse
the
function.
Of tan.
The inverse function. So this is limit as x goes to 2 positive of inverse tangent 1 over x minus 2.
That doesn't exist.
Okay, if we plug in 2 right now, we're going to have a 1 over 0, which means it's undefined. It's not possible to find an undefined limit. And you may be tempted to say that it is just undefined, but it's not. We got to have a way of proving that it is for sure undefined. Therefore, we're going to do some change of limits. So what we're going to do is break this part out. We're going to figure out what that limit is first. So we're going to evaluate the hardest part, or the part that's giving us the undefined part, which is 1 over x minus 2. We're going to figure out what that limit is first. Okay? Limit as x goes to 2 positive of 1 over x minus 2. Think about it. Do not use your calculator. Which direction does it go? Infinity. Okay, once we figure out that part, we're going to now change that problem or plug it into the original tangent problem. Remember now we know that x is going to infinity. This problem changes to inverse tangent x because we already evaluated this part, 1 over x minus 2. That's infinity. Therefore, this part is just going to be x. This part is going to infinity. This is called a change of variable. Next, tangent, inverse tangent. You have to remember how inverse tangent looks like, not tangent function. Inverse tangent.
It's the funny one.
Inverse tangent looks like this. If you don't remember it, please graph it on your graphing calculator and memorize it. You cannot use your calculator for this. Okay, so the question is, what are these? So when x is going to infinity on this inverse tangent graph, where does y go? You got to remember the asymptote. Pi over 2. So this is going to pi over 2. So there is a limit. The limit is going to pi over 2. And you cannot evaluate it with the traditional way. You have to do change of variable. Yes?
This whole thing depends on us memorizing.
Yes, you have to memorize the graph. Yes? Squeeze theorem, there, I don't think, because 1 over x squared, x minus 2 is not squeezed.
No, but like we do like one of the thing and then do the other thing.
Oh, kind of, yeah, you're right.
Or when do we know that when to do that?
When you cannot evaluate it as is. Okay, let's try another one. This one. The infinity matters. We changed that limit to go to infinity and not to plus anymore. Change a variable. Okay, let's do this one, everyone. Remember, the issue is that at this time, if you plug in 0, you're going to have an undefined limit. Therefore, you got to do change of variable. Okay, let's kind of look at this together, and I'm going to give you a few more to practice. First, can I plug in 0 right now and get a limit? No. So I need to break this function apart. Which part is giving me the problem? 1 over x. So what I'm going to do is I'm going to evaluate what is happening at 1 over x when 0 is going to negative side. Negative infinity. At this time, now I figure out, oh, that part is actually going to negative infinity. I'm going to change my variable so that it's now going to negative infinity. My function is now e to the x because I already evaluated 1 over x. Now think about e to the x. When x is going to negative infinity, where does where does y go? 0. Okay, so this is how you use change your variable when things are hard to evaluate. Okay, I'm going to give you a function. We're going to do 3 different limits. 2 plus 3 to the 1 over x over 7 plus 3 to the 1 over x. So this is the function.
What's the limit?
Copy it down first. I'm going to give you 3 different limits. All right, first question. First question, limit as x goes to infinity. Okay, figure out this one. All right, let me go down the line and see what numbers you got. George.
3
Okay. Sky. Okay. Raymond? Robin? Jim? 2 7s. Elizabeth?
I was gonna say 0 or 1.
0 or 1? Which one?
2.
Yes. 0.
Sophie? 1. Okay. Jean? 1? Huh?
I did that usually, and I was like, oh, wait.
Shauna?
Yeah, and then they add.
Okay, 3 over 8 is the correct answer. Remember, shh, guys, please be quiet. 2 plus 3 to the 1 over infinity over 7 plus 3 to the 1 over infinity. 1 over infinity is 0. 3 to the 0 is 1. So that is 3 over 8. Again, please do not assume anything. Just plug it in. You'd rather be correct than wrong. Okay, second. Obviously, most of the things in life. Okay, limit as x goes to 0 plus. Change the variable. Answer?
3 over 8?
I don't know.
1.
We're taking the whole 1 over x and making it x.
Okay.